Thank you, London. Thank you for having us, KX. Thank you for braving the rains and cold rains to come here. And so I think one of your customers is Red Bull, so I want to sponsor them. So how many of you have used KX before? Hosts first. How many of you have used or heard of H2O? A lot of new faces to talk H2O about as well. KX is obviously phenomenal and has a stellar reputation in time series amongst our customers as well as the wider audience. And we are really excited at the partnership with the team. Mark and the rest of the team have been extraordinarily great in extending their hand of friendship. And as far as machine learning and AI goes, we would love to see nothing but great results from the two teams and wow audiences worldwide. So this is probably just the beginning. Mark was keynoting our conference earlier this year, about a month ago, in San Francisco, and we got a tremendous reception waiting for us in the marketplace as we bring the two products and a bolder vision to play. What you're seeing here is obviously a time series demo of driverless AI, H2O's second product. H2O is started with a mission about how many of you have a .ai domain? We were the second .ai domain, Antigua Island. And so we're famous for that, making this domain famous. But our mission was actually to democratize AI, to make machine learning accessible to wider audiences. When we started about the best houses that build algorithms at scale were Goldman Sachs or Google or a few like Amazon and others. You'll hear from some of them. But we built some of these algorithms at scale in open source and built some really high-grade engineering and gave it out to open source. Some of the largest companies in the world today use H2O, and our open source kind of taught us that giving comes back in spades. Today, about 18,000 companies use our product, and it's embedded in a lot of places. It's being used as applications because we produce code from data. The mission of the company is how do we produce code from data. It's probably, if you're not in the data science land, you haven't heard of us, but it's a reasonable phenomenon in the data science world. How did we get here? The vast bulk of our core engineering started with compiler systems thinking, and a lot of physicists behind the product. We work very closely with the mathematicians of our time, some of the best math that's been happening in the last few decades, starting with random forest to generalized linear methods, to even boosting methods, deep learning, several variations of the theme on deep learning. So we built that with a lot of folks from physics. How many physicists in the audience? We are hiring. So we can hire physics. Basically, the physics of the product is the physics of the team. But if your team is filled with physicists, you're a good chance you'll be able to simulate and understand complex systems. We also found out that data scientists began to trust our products and started winning contests. Data science, how many people call themselves data scientists these days? Pretty sure a large population. Data analysts, data scientists, data engineers. Data scientists started following what we call competitive data science in Kaggle. And so we found that grandmasters, some folks in the audience, a few from H2O as well, have been competing in public contests and trying to win. And these grandmasters ended up defining how the space runs. So we've slowly started adding to our team grandmasters whose recipes then end up becoming automated. So when I started the topic of AutoML, the recipes needed to automate machine learning are designed, so the grandmasters are our chief architects of our product, driverless AI. Obviously, the next phase is to try and partner extensively with domain experts. It's a global team, and obviously we are here because of the amazing work from the team. Data is a team sport, and I'm sure you've heard of this before, but really, most business apps are coming straight from domain. But on every edge of this picture, there is a lot of violence, right? We call it team sport, but really, on the edge of these is where people innovate. There is culture, there's clash, but because of this culture of the clash of good ideas, you create new things. So one of the things that H2O does is connect this side of the picture, where we are able to connect data and use algorithms to produce code. The code then funds business applications. Obviously, design and how you get customers to react and give feedback, that's where a bulk of the innovation is still ahead. Time is the only non-renewable resource. There's a philosophy that we follow a lot, think about, is this one, because our people can buy back other things, but time is still linear. It's growing on one direction. Until we invent time machines, of course. There's one other favorite slide of mine that I just drop in there so that people, we wanted an AI revolution, and that we really were looking for this movement. Even as the company was started, I was looking at the early makers at KDB and KX, and I was hoping that one day this movement will come, and I'm quite excited that it's come. All life is actually time series. We think that time is so, while KX is so respected in the financial services, I think it's about time to take that and go all over. Because we see time series problems everywhere. Sensors, right, obviously vehicles. We are seeing time series in weekly sales predictions to across, the gamut of opportunity of applications is off the charts. But that's still just the beginning, right? We think of this as ML leading to AutoML. Automatic machine learning is your compilers for the machine learning space. So our open source products, all math at H2O is free and actually is open source. And so any math algorithm we build has been open source for the last 7-8 years. We've been innovating in the space. But I think automatic machine learning is where you can now start generating the right parameters, the right features, and the right settings for including the hardware needed to run below here, so that now you can auto-generate a lot of the machine learning needed to solve big problems. That will lead us into the future where AI-first applications will be everywhere. So almost all applications will be moving away from rule engines to automatically generated rules called scoring engines or inference engines that will then be part of every app. And that's where the AI App Store, we're seeing some examples of these happen already, but I think that's kind of where the continuously learning containers, as the data is coming in, you want to recode the new rules based on the latest data that arrived. And that's kind of where you're going to see a lot of innovation happening today. So we're in this era of you can call the AI space. A lot of the algorithms are being innovated continuously. If you think of PyTorch or GANs or all the newer innovations happening, but really automatic tuning of those and then embedding of those into applications is kind of where you're seeing the bigger changes happen. What is the role of different people in this space? Typically, data engineers are obsessed with data, and data scientists are on the receiving side. So data is arriving at much faster pace, and data scientists have to continuously build those pipelines to feed and improve, obviously, both the data culture across the companies. CXOs and strategists are essentially looking for applications to feed today we are feeding them PowerPoint charts, right? Sort of the BI charts, if you will. But I think what strategists, eventually scientists are going to go and start defining strategy. So you're going to see a lot more of strats doing science. And it's already happening, obviously, in the quantitative trading floor. You see a lot of that happen today. I think the notion that data scientists are going to elevate and start doing strategy across companies as chief decision makers in many places, I think that's already emerging. And the rate at which companies learn will be the rate at which these pipelines are built and not at the rate at which data is being created. So, sorry for the wide glare here. In order to operationalize your data and the pipelines, you need to auto-generate a lot of these, lot of the code that goes into the edge. So when H2O is being used to learn from the data, the model training, the automatic generation of scoring engine operationalizes most of these models. That operationalized code object, called, in this case, Java object, then gets embedded into applications or on the edge, on the sensors. And after that, you're kind of free. In some sense, the edge is only scoring. The future, of course, is when edge is also learning and not just scoring. So this is the current usual typical way of deploying our products. And with KX, I think we see that we could be impacting both at the training side, basically including feature engineering on time series, to the deployment side, where we are able to embed this object into Q, right? And then essentially enable several folks who are already using Q to do their time series manipulation, run their scoring engines right where the data is already sitting. Eventually, we anticipate all the learning to also be happening here, all the way on the edge. So you're going to see a continued partnership to bring AI and time series across the end-to-end spectrum. And at different places, we're going to expose it with different user experiences. But the user experience at the middle level is actually the easiest and the first one to come. The user experience on the in-database scoring, which enables H2O models to be trained in KDB without taking data out, is going to happen on the cluster. And then finally, actual deployments where time series is happening on the edge and learning on the edge is going to happen. So this is the kind of place where we see kind of the partnership emerge and AI for time series become more widely deployed. Obviously, H2O as a whole, driverless AI, we do automatic feature engineering and time series, a son of NLP. And there's a combinations of these three happening all the time. Data is not either only one of them. You'll see data that is NLP. A column will be a description column, and another columns are all sensor data. So you're going to see a mix and match of all these, which is where the real interesting, nutty problems are. And eventually, we expect our audiences to build their own recipes. The product is divided into lots of recipes, and those recipes are stitched together to solve a whole class of problems. The rest of the architecture is actually to enable deployment and having a whole model lifecycle management come to fore. And this is kind of the core architecture behind driverless AI. Lastly, AI is as good as the story one can tell. Right? So if we cannot take the story to our boards or officers, we are going to be lost somewhere here. Right? And so enable to breaking down the problem and telling a story on why the machine learning did think the way it thought is actually going to be a substantially big part of AI as well. This is using AI to explain AI. So without further ado, that's a lot of PowerPoint for the day. So I'm going to jump into the product. While we were watching earlier, actually, let me just start from the beginning. The product actually runs on-prem. It runs. So we can. So there's a long road of partnership ahead, but it doesn't look that long as we broke that down to pieces. But one of the easiest ways, the current existing uh, uh, easiest way to kind of integrate, we are already integrated at the connector level. Um, so you can connect your source and plug in and get data sets. Out of the box, the S&P it's a small data set, actually. It's not the large data. It's just a very simple open-close kind of data set. You can get some out-of-the-box outliers. This is automatic visualization in the product. But the idea is that predicting for us is usually more of a game in the sense that we're using the recipes built by the grandmasters in using the right kind of division of labor, if you will. Both from, I'm going to pick some date is the primary time column here. There's a secondary time column, which is the name of the stock. And to our left here is actually the recipes needed to do feature transformations. Some of them are just simple interactions. Some of them are taking the date and checking if it's a holiday. Right? That's an interesting transformation that left. Some of them are truncated SVDs to linear. If there's text running, kind of. So this is actually an advanced techniques that plugging in TensorFlow or plugging in kind of more of a streaming models, follow the regularization leader, rule engines, kind of picking different kinds of techniques as well, frameworks. And the three big knobs in the product, accuracy, time, and interpretability. And I'm going to try and reduce time because not many of us have time in the current world. Interpretability is another interesting setting. If you have GPUs, you can enable GPUs, or you can run just regular CPU-based systems. And the idea here is when you launch this, you're essentially building essentially figuring out if the test data is right. It's a one-day forecast horizon. It picked the forecast horizon. And there's common pitfalls in building models, such as overfitting, right? Or leakage of test and train. And figuring out if you have a good representation of the holiday data, if you have a good representation of the weekend data. If there's some common collinear columns or constant columns, those get dropped right away. And the idea here is that we are kind of creating a way to both transform the features, find the right parameters for the algorithm, and then build the model itself. So we're doing a lot of model building here. Each bar here is a full-fledged model. It's green because it's running on a GPU. It's not green. I mean, we know that not everything green is organic. But this is running a GPU, and then you're scoring, essentially. So it's feature engineering, transformation of the columns, parameter tuning of the model, and the actual model score, and the model build, and the model score. So this is actually a continuous model build to essentially improve the accuracy of the model. So obviously, in the first cut, you have a lot less, if you will, interactions. But over time, this is running a genetic algorithm between these epochs to continue to improve the accuracy of the model. Since we actually ran the model earlier, as you can see, it starts dramatically dropping to a model with a very low RMSE error here. And another way to do the next piece, things that the product allows you to do, which is build a history of the model, a history of how the model was built, and so on and so forth. I'm going to pick up one of these previously built models and pull up an easy kind of interpretability of the model. So let's see if you have an interpretation here. Meanwhile, our launch actually has dropped in accuracy, dropped in error. You can see one of the transformer exponential weighted moving average, which is one of my favorite lag variable, lag max. Turns out the high previous and low previous day are still the top players, top features that have variables that have importance. Interaction, add interaction between high previous and open previous. So you're beginning to see kind of what a very good modeler will be picking up. Interesting features in being able to predict the accuracy of the model. I'm going to try and get some good MLI here. MLI being, see if I have one of these. So the idea here is now that I have built a model, can I understand it? So remember the claim around how to predict. So the yellow line is the history, and this is the future. And so the idea is that can I get a story? What are the top 10 features that led me to predict that Apple's stock is going to be 163 or such on that particular date? So trying to understand kind of not just the model, but also the dimensions that led to those features. I'm going to pick up another model here and kind of try to give English meaning to these models, right? So the key piece is how do I break it down to something I can consume and then take a story. Here's another way we understand models. This is the original prediction, and this is the surrogate model that's overlaid on top of that. And so the surrogate model gives me a way to understand the decision tree. This is a decision tree surrogate. This is a partial dependency plot, and this is just a linear surrogate. And here, this model then gives me an English explanation to why a particular, sorry, we can't see the red at all here, but why a particular, what were the reasons, kind of the reason codes between why a particular person was more likely to default, which was a default payment prediction model. But the idea is that trying to break down, this Shapley again, Shapley for this particular model, trying to break down the why, right, sort of, and make that consumable for the business audience. A bunch of interesting things were basically built along the way to kind of continue to make the model robust and try to kind of reduce bias, reduce susceptibility to biases in the data. And some of that include ability to kind of find the right kind of gaps and make sure we pick the right kind of validation schemas as you split your data. Essentially, you're trying to make sure the window that you picked as your validation window doesn't become the most important aspect in your time series modeling. So I think, suffice to say, there's a lot of interesting techniques, and H2O is going to now start bringing those to the low latency, high frequency spaces that are dominant in the true sensor world, in the sensor-rich world, both in IoT as well as in finance and rest of the telcos. We're seeing a lot of telco customers demand kind of a much more high-grade AI on high-grade time series systems. I'm going to kind of leave you with other interesting things that are on the way. We've installed our product. Turns out how the gravy zebras grow is also a time series, and using AI and time series to save lives, save wildlife and lives is actually something that excites us. H2O is free for all wildlife conservation, so hopefully we'll be able to get things together. Data science is really a search for truth, and so and you'll see most data scientists, when you ask them, they're almost always unsure because they're so studied in the space. They want to make sure that they're absolutely right with an AUC1, which is hard. But all knowledge is really driving us towards more discovery. And the greatest discovery of all is to see how the human mind works or how we think. And that's kind of something we're really passionate about. We're also very passionate about building a very authentic culture and building a widening, expansive thinking as opposed to narrowing down things. We like to be the change that we wish to see. We actually think that a large part of this is going to lead to wider use. So as AI comes and takes a lot of the things that are mundane and the day-to-day of our work, will now begin to be valued for being more human, which drives the point around empathy as well. I started with the only non-renewable resource. I think the only renewable resource is love, actually, and we think that you can beat time with enough passion. And the only force, the strongest force we have in the world is actually love, and we think that this is going to really bring bigger change across. So thank you so much for having me.